Hi again. Today's lesson is on the last exponent law that we have, the rational exponent law. Now, before we go into it, we should understand what the word rational means. So, when we define rational, this is a number that can be expressed as a fraction. So, for example, we have a to the power of m divided by n. The rule states that we can rewrite that as the nth root of a to the power of m. So let's take a look at that more carefully. We're going to introduce some vocabulary along the way. So first of all, this entire thing is called our power. And on the other side, this entire thing is called a radical. When we look at our power, we know that a is called our base. And on the other side of the radical, a is no longer our base. Instead, this is called the radicand. M over n is our exponent. So I'm just going to put exponent here. And where m is our numerator and n is the denominator. You'll notice that the denominator, n, became the number that's outside of the root. So we call this the index number. And it came from the denominator. The m, which was the numerator, is still the exponent. So we'll notice that in this case, the denominator became the index. And the numerator stays as the exponent. And then base became our radicand. So how do we deal with these radicals? Now remember our order of operation. We had bedmiss, but now I'm going to talk about breadmiss. Breadmiss as in we're introducing R for radical. So radical and exponent, these two are on the same level. So it doesn't matter if you do your radical or your exponent first, as long as you're going from left to right. So our radical and exponent are opposites of each other. For example, you'll probably remember in Pythagorean relation, when you get to the c squared is equal to a number, or in this case, c squared is equal to 25, the opposite of the square is the square root. So opposite of square is the square root. Now, our square root, it doesn't have an index number because it is assumed that it's a 2. So no index means 2. Okay, let's do a few more examples here. So now we have example 1. Rewrite these powers as a radical. Now we remember that our exponent as a radical, the number at the bottom, so the denominator becomes our index. So I'm going to rewrite this as a root. 3 is my denominator, now it's the index, and I have m to the power of 1. Or I can say third root of just m. In the next example, I'm doing the same thing. I have cube root, because 3 is the denominator, of 8 to the power 2. Now, the way we would read this is we would say the nth root, so this is our denominator, of a. This is our base. And then if it's something, we could say squared or whatever our exponent is. Now, another question. Let's rewrite the following radicals as a power. I have third root of x to the 7. Now, we remember that our index becomes the denominator. So I'm rewriting this. I have x to the power of 7 over 3. My next example, I have the root of 6 to the power of 3. Now, if I have no exponent there, remember we said the assumption is there's a 2. So it's the square root of 6 to the power of 3. So when I rewrite it as a power, I would have 6 to the power of 3 over 2. Now, how are we going to deal with this on a calculator? Your calculator may have different buttons that will help you. So you might have an exponent button like that. On top, you might have an X root button. I'm just going to write down all the popular ones that you see. Sometimes we have a square root that is a triangle. Sometimes you'll see y to the power of x as your exponent, or sometimes you'll have x root. So, for example, if we were to solve this question in our calculator, what I would type in 98 exponent, and I have to make sure I have the bracket. The bracket to show that the exponent as a fraction is together. So 2 divided by 3 and close bracket. If we're using this one, I would do exactly the same thing, except instead of using that exponent button, it would be y to the power x, bracket 2 divided by 3, close bracket. Now, if your calculator has the nth root button, what you would do, we would type in the root. So this is our cube. You'll usually have to press shift or second function. And this button, which on my calculator would be the YX button. Then I type in 98 to the exponent 2. Play around with it. I'm just going to show you how I do it. I have 3 nth root of 98 exponent 2, and the answer is 21.256. So in this case, it's given me 21.256. I want you to try that with your calculator to see how your calculator works. Does it work this way, this way, this way, or none of the ways? Some calculators like you typing things in backwards. So you might have to type in this, shift, and then that button. I'm not sure, but I would like you to try. And if you get stuck, you can send me an email for us to figure it out together.